Good day everyone. In the last video, you learned two properties of definite integrals. In that, second property was integral minus a to a f of x dx is equal to twice integral 0 to a f of x dx if f is even and it is equal to 0 if f is odd. In that, you learned two examples. Now let us see 2-3 more examples where sums are a bit different and how we have to handle it. Now let us see example 1. I is equal to integral minus a to a root of a minus x by a plus x dx. Here, at the face of it, no, it looks like you can apply the property that integral minus a to a f of x dx. But here, your f of x is root of a minus x by a plus x. If you find f of minus x, that will not be equal to f of x, that will not be equal to minus of f of x also, because you will be actually getting a plus x by a minus x only. So, we won't be able to proceed at all. We won't be able to find whether it is an odd function or even function straight away. So, here what we have to do before going to that property is, first, let me conjugate, okay? So, root a minus x by a plus x. Now if we conjugate, we can write no into a minus x by a minus x dx. So now what happens? You get minus a to a. In the numerator, you get root of a minus x the whole square. So the square and root will cancel each other. You will get a minus x. The denominator becomes root of a squared minus x squared dx. Now you split it into two integrals, right? So now for the first part, you can take that a out because it is a constant. 1 by root of a square minus x square dx. For the second part, take the minus out. So you will get x by root of a squared minus x squared dx. So now I can write my I is equal to ai1 minus I2, okay? You put a box for this and mark this as 1 because this is the final answer step for us. Now, we have to do I1 separately and I2 separately by applying that property. Now, I2 is simpler, so let me do I2 first and then I will come to I1. So, I am taking now I2. I2 is integral minus a to a x by root of a square minus x square dx. Okay, here what is the f of x? X by root of a square minus x square. Let me find what is f of minus x. That x will become minus x. Here you will get a square minus x square again because minus x the whole squared is nothing but x squared. So you are getting now f of minus x is equal to minus of f of x. So you know f is odd in I2. So I can write the I2 is equal to 0. You can write the property. What is the property? Integral minus a to a f of x dx is equal to 0 if f is odd. Okay. So I will mark this as 2 and keep it. This is one part of my answer. Now let me go to I1. The I1 is a we have taken already out. So the I1 is integral minus a to a 1 by root of a squared minus x squared dx. Now what is the f of x here? F of x is 1 by root of a squared minus x squared. F of minus x is 1 by root of a squared minus x squared because minus x the whole squared is x squared. So here f of minus x is equal to f of x. So f is even here, right? So now the I1 becomes by that property twice integral 0 to a 1 by root of a squared minus x squared dx. Let us write that property here. Minus a to a f of x dx is equal to twice integral 0 to a f of x dx if f is even. Okay. Now, this is a straight formula, you know. So, you will get 2. This is sine inverse x by a within the limit 0 to a. So, you get 2 into sine inverse 1 minus sine inverse 0, right? So what is sine inverse 1? It is pi by 2. Sine inverse 0 is 0. So you get this as pi. So your I1 is equal to pi. Mark this as 3. Now you substitute the 2 and 3 in 1. So you will get I is equal to A into pi plus 0, which is equal to A pi. Do you understand? So in this sum, straight away you are not applying that property, but you are first conjugating, splitting it into two integrals, then you are applying that property and you got the result. Okay, is this sum clear to you? Let us see example 2 now. I is equal to integral minus pi by 2 to pi by 2 mod sin x dx. When you have in f of x some modulus function, either straight modulus or even some modulus function inside, definitely you cannot use the property for odd function and even function. So if you have a modulus, always remember the property you have to use is only integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. So in spite of this limit being in the form minus a to a, you have to use only this property. Make a note of this point. This is important. So now, as usual, I will proceed. I will equate whatever is within the modulus as 0. So I get x is equal to 0, which lies between this minus pi by 2 to pi by 2. Come to the number line. This is minus pi by 2. This is pi by 2. I have 0. So the two intervals are minus pi by 2 to 0 and 0 to pi by 2. You know this is fourth quadrant and that is first quadrant. Sin x is negative in the fourth and sin x is positive in the first, you know. So let us now write our I is equal to integral minus pi by 2 to 0. Okay, it is negative. So you write now minus sin x dx. Then plus the second interval is 0 to pi by 2. Now the mod sin x is positive. Okay, when x is greater than or equal to 0, that will be positive. So you can write it as sin x dx. So here we are not using that odd even property at all. Now it is like two different sums now. So take a minus out. For sin x, you know, if you integrate, you will get minus cos x. The limit is minus pi by 2 to 0. And here, a plus here, and here also you will get minus cos x. The limit is 0 to pi by 2. Okay. So minus into minus, you will get a plus here. So you will get cos 0 minus cos minus pi by 2. Then plus, you can take this minus out actually. You can write a minus cos pi by 2 minus cos 0. You all know cos 0 is 1 and cos pi by 2 is 0. Even minus pi by 2 is cos pi by 2, so 0. So you will get actually 1 for the first part, 1 minus 0. There is a minus here. Then it is, here it is minus 1. So 1 minus of minus 1. So 2 is your answer. So do you follow? Here the limits are like minus a to a. But the inside the f of x function is a modulus function. So use the property of modulus only and then you do the integration as per that procedure. Is it clear to you? Now let us see another example which is also a bit different. Here I is equal to integral minus pi by 4 to pi by 4 secant squared x by 1 plus e power x dx. Here the limits are again in the format of minus a to a. If you have secant squared x, you know it is an even function because secant x itself is an even function and the power is even, that is an even function. But when you come to this part, when you consider an exponential function, you cannot put it under any category. It is neither an even function nor an odd function like that, because e power minus x, if you take, no, that is not equal to minus of e power x. It is not equal to e power x. So your f of minus x is not equal to minus of f of x, or it is not equal to f of x. So I cannot use that property in this sum also. So here I am going to proceed in a different way. I am just thinking what property I can use here. When I have e power x, if I get some e power minus x somewhere, I can write it as 1 by e power x and I can try to do something. So I think of this property now. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx, because my a is minus pi by 4, my b is pi by 4. So a plus b is 0. So a plus b minus x becomes there minus x. So I am going to use that property. So let me mark this as 1. Okay. Now I will use this property. So I will get my I is equal to integral minus pi by 4 to pi by 4. Okay. Here I will get secant squared 0 minus x, a plus b minus x, a plus b is 0, 0 minus x by 1 plus e power 0 minus x dx, which is equal to integral minus pi by 4 to pi by 4 secant squared of minus x. What is secant squared of minus x? Secant squared x. Okay. Because that will be secant squared x plus 1 by 1 plus e power minus x dx. Now I can write that e power minus x as, I will write this 1 plus 1 by e power x dx, right? Now take LCM for the denominator and take the e power x to the numerator. So you will get minus pi by 4 to pi by 4. I will get e power x secant squared x here. Here it will be e power x plus 1 dx, right? Mark this as 2. So the given sum is 1i. You have used this property and you have simplified it. This is your 2. Now as usual, you add 1 and 2. Whenever you use the property that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x, or this a plus b minus x property, you will put 1, 2 and most of the sums you will be adding that 1 and 2. So the left hand side will now become 2i and to the right hand side we will be getting, let us check the denominator first, 1 plus e power x, here e power x plus 1, both are same. So let me write 1 plus e power x. Let me come to the numerator. Here I have secant squared x. Here I have e power x secant squared x, right? Write it, put a dx. Now in the numerator I can take one secant squared x common. I will get 1 plus e power x by 1 plus e power x dx. Cut these two. So what do you get now? You get minus pi by 4 to pi by 4 secant squared x dx. Right? It is very simple. Actually, I can straight away also proceed, or I can use that odd even property and proceed, because sometimes no, both will be possible. Anyway, let me show you how to use that property. Secant x itself is an even function, you know. Secant squared x is even, so I am straight away writing f of x is even. Okay. So by using that property, I get here twice. Here you have 2i, remember that, you should not forget it. Here I will get 0 to pi by 4, okay, secant squared x dx. Because it is even, I am using this. So this 2 and that 2 will go. If you integrate secant squared x, you will get a tan x 0 to pi by 4. So you will get tan pi by 4, which is 1, minus tan 0 is 0, so 1. So now for this sum, you get the answer as 1. So now the 3 examples which I explained in this class, you must remember, because the first one we conjugated, we split it into 2 integrals, then we used that odd even property. In the second sum, it is modulus. So we didn't use that property, we went as per the modulus property. Then in this third sum, here also the limits are like minus a to a, but here also because of the exponential function I cannot use that property. So I am using some other property and I am solving. Hope you are clear with all these things. Thanks for watching the video. Subscribe to the channel and click the bell icon so that you will get further notifications of the videos. Thank you.